was a kid at school, the idea of the scientific revolution was completely and utterly ingrained in the way that we were taught about the glories of European civilization. But it was a revolution without much blood spilt. Galileo may have been put up in front of the Inquisition, but very few of our scientific heroes ended their life on the scaffold. It was also, epistemologically, a very strange revolution. A revolution that was based upon acts of lone genius, the genius of a Bacon or the genius of a Newton, leading to breakthroughs that were hardly breakthroughs at all. What they seemed to be was the gradual accretion of true and worthwhile knowledge. This, as we'll see, is a very positivist way of thinking about the notion of scientific development. But what I want to do in this particular module is introduce the ideas of Thomas Kuhn, which suggest that although they might not have been physically violent, scientific revolutions had their own metaphorical and intellectual violence, a view that shifted us away from the idea of the slow accretion and progress of scientific knowledge. Thomas Kuhn, one of the most influential figures in the history and philosophy of science, a trained physicist who turned his back on physics and went over to the dark side of philosophy. Once Kuhn had published his ideas in the early 1960s, our view of scientific revolutions would be completely, utterly, and irretrievably changed. But to understand the extent of his influence, we have to know something of what went before him. Now, the traditional view of scientific progress before Kuhn was what we would call Whiggish. Whig being a term applied to a certain kind of history that focuses upon progress at all costs. So the traditional view of scientific progress is that it accretes slowly. A breakthrough is made and then another breakthrough. Things are found to be false and are discarded. Fact upon fact upon fact is gradually built up. Our picture of the universe improves. And this tied up very nicely with the positivist view of science. The logical positivists believing that only knowledge that could be proved through a combination of sense observation and logic was true knowledge. Now, this view was challenged from the 1930s onwards by the great philosopher Karl Popper. Karl Popper was no fan of the logical positivists. Indeed, he thought their ideas were distinctly unsound. For him, the major problem that science faced was the problem of induction. Now, here we have to remember that when Bacon, during the 17th century, came up with his version of scientific methodology, he emphasized that the most important thing for a scientist to do was to collect facts and collect them without having their hypotheses shaped by preconceived ideas. The job of the scientist was to observe, to collect data, and then once the data had been collected, to form theories that emerged out of the data. And this method is the inductive method, and it is the method to which scientists rhetorically adhere. Now, Popper, of course, when he addressed the nature of induction, was addressing the problem that had been identified by Hume in the 18th century, the problem that was at the heart of a science that believed that the collection of facts should not be shaped by preconceived ideas. The problem of induction can best be described by looking at the case study of the swans. If you're a European up until the 18th century, you travel around and you see swans everywhere, and all of those swans were white. Therefore, inductively, you could conclude that all swans were white. But then the frame of reference changes. Exploration opens up new lands. The coast of Australia is explored during the 18th century. And lo and behold, the black swan is discovered. So induction can never complete the picture. And this was the problem that was recognised by Popper when he looked at science. He believed that you could never establish absolute truth through the scientific method. Science therefore proceeded on the basis of developing hypotheses that could be falsified. And if a hypothesis was not capable of being falsified, then the realm that we were working in was not science. For Popper then, science proceeds on the basis of deriving theories from facts and then testing those theories, and at some point, if the theory does not stand up, discarding it in favour of another theory. Now this idea was challenged enormously when Kuhn published his celebrated work, The Structure of Scientific Revolutions, in 1962. This work has had an enormous impact on the way that people think about not just science, but the world in general. The book itself is extraordinarily radical. Kuhn himself at various times tried to distance himself from how radical the conclusions were that could be drawn from his work. But the fact was, when you explore it, it opens up the ground for a relativist view of the universe that has been incredibly distasteful to many, many commentators who are favourable towards the scientific project. Fundamental to this work was the idea of the paradigm. A paradigm being a way of thinking about the world to which all people at one time adhere. So a scientific paradigm is basically the rules and objects of science at any given time. Now Kuhn, according to his own testimony, developed his ideas when he was thinking about the difference between Newtonian and Aristotelian science. And at the time, he was working on his PhD in physics, and he was thinking, how could Aristotle have got it so wrong? How could he have got it so wrong? And then, as he was looking out of his dormitory window at the leaves of the trees below, he had this sudden moment of insight that actually the Aristotelian view was just a different way of knowing to the Newtonian view. And the thing that was really radical was that he suggested that neither view could be privileged over the other. They were just the way that people thought at a given time, structured by the nature of culture and the world. At times, Kuhn would try and distance himself from this extraordinarily radical view. It is quite striking that when he, in Hacking, thinks about issues around the social construction of scientific knowledge, and he looks at Kuhn's book, he rates it as being highly constructivist. Indeed, Hacking has 3 different sticking points that he looks at when he tries to assess how strongly constructivist a theory is. The first of these is contingency. In other words, was it inevitable that a particular discovery would be made? Was, for example, natural selection inevitable? And if you score 5 on the contingency scale, it means that natural selection wasn't inevitable, or quarks weren't inevitable. So that's one area. The second area is nominalism. In other words, the relationship between what we call things and the underlying object that is being named, and whether there is a strong relationship between the two of those. And again, 5 means that you believe that the relationship between a name and an object is arbitrary. And the third area was the stability of science. How stable is science? And what happens when science changes? If you think that science isn't very stable, then you're on the constructivist end of the scale. In all of these areas, Hacking rated Kuhn at around 4 to 5, which suggests that from his perspective, this account is highly constructivist. And it's no wonder that scientists felt that they were being attacked, because the ideas that Kuhn developed opened up a whole realm of relativism and constructivism that undermined science's view of itself. Central to this, then, was the notion of the paradigm. Paradigms adhere to a commonly accepted set of rules that define a number of things: the objects of study, what is to be observed, what questions can and should be asked of the objects, and how the results of the observations can be interpreted. It is the scaffolding around which science is built. In normal science, problems are rejected or accommodated, fitted into the structure itself. And in revolutionary science, the paradigm breaks down under the force of a new revolutionary theory, which becomes the new paradigm, the new normal. Now, in the previous module, I looked at the paradigm shift when we moved from the Aristotelian Ptolemaic view of the Earth's place in the universe to the Copernican view, from geocentrism to heliocentrism. In Kuhnian terms, what had occurred was that as more and more observation had been going on, exceptions had built up that had been accommodated within the model, accommodated and accommodated and accommodated, until we had this incredibly complex view of the motions of the planet as we attempted to accommodate them with the idea that the Earth was at the centre of the universe. And then along comes Copernicus with a completely radical view that changes the rules, that changes the paradigm. A revolution, a new paradigm, a new way of knowing the world. And critical to the Kuhnian view was the idea of incommensurability between paradigms. In other words, they were like two countries with two different languages, neither country being able to translate between those languages. The gap between one paradigm and another is vast. It is so vast that it is unbridgeable. Now, the questions that emerge from this are the extent to which Kuhn got it right, whether these are good rules for describing revolutionary science. And this gives us a framework to think about Darwinism, but we can only do so if we look at where Darwinism emerged from and where it developed to. And this will be the subject of the next modules.